I'm Lee. I'm going to introduce structure of X random variable and modeling. Okay, this topic may be pretty interesting and unique explanation about model. I'm going to introduce models in this chapter, ANOVA. So if you understand structure of X, then you will understand models easily, I believe. Okay, let's see what is the structure of random variables. Let's take a closer look at random variables. We represent them as random variables because we do not know the values of population. Population is pretty huge, so we do not have the data. We do not know. So we say let X be the population. Since these values can take on various outcomes, we also say that random variables follow a certain probability distribution. This follows some distribution f of x. I told you. Okay. Now we take y instead of x in this chapter. All right. Here, consider random variable y as the sum of mean and error epsilon. That is, random variable y consists of its mean plus epsilon. Epsilon is a Greek letter pronounced epsilon. Okay? So mu plus epsilon. This is basis of model in the future. The error refers to the difference between the measured value and the true value. You understand error? For example, if the true length of a product is exactly 20 centimeter, but the measured values can be 19.8 centimeter, 19.7 centimeter, and 20.1 centimeter, and so on. Okay? The error would be, for this error, 19.8 minus true value, minus 0.2 centimeter. For this, minus 0.3 centimeter. For 20.1 measured value, the error will be 20.1 minus 20, respectively. In other words, the reason that the values of random variable y varies, we do not know the value of y, is that the error takes on different values. Since the error takes different values, that's why random variable y varies. Understand that? This structure. Now, let's discuss the error, epsilon. The error, epsilon, is usually assumed that error follows normal distribution with mean 0. Okay? Mean of error is 0. It is natural, I think. And error takes some values, so error has variance, sigma square. We assume this one in statistics. It is natural to assume that the average of errors is 0. The assumption that the error follows normal distribution is also quite reasonable, quite rational. Okay? Since error occurs for various reasons, error occurs for various regions, which can be the regions can be denoted as S1, S2, Sn. There are many regions for error. Let S1, S2, Sn. We can think of these as having different weights. These regions having different weights that contribute to the error. In other words, the error can be considered as a weighted mean of those regions, i.e., error is a weighted mean of regions, S1, S2, Sn. This is weighted mean. Okay? So this weighted mean is what? S bar. Understand that? weighted mean, but anyway, it is a mean S bar. There can be quite a few those regions, and it is not unusual, it is usual or not special to assume that eta epsilon, which is weighted average of those regions, follows a normal distribution. Why? According to the central limit theorem. So, I mean, the distribution of eta follows normal distribution. It is, you know, natural. It is not natural sometimes, but you may understand it is reasonable to assume normality. Get it? Thinking of the random variable y as the sum of what? Mean of y, okay? Random variable, mean of random variable, and the eta is a fundamental model used in statistical theory. So y is mu plus its mean, mu plus epsilon. And epsilon follows normal distribution like this. So y follows normal distribution with mean mu, variance sigma square. How about this? You understand that? Okay? So it is, we are going to use this kind of a structure and normality, normal distribution of y. That is base of model. Let's see, modeling. Let k populations be denoted as y1, y2, yk. Okay? K populations denoted by y1, y2, yk. And let the mean of each population be mu I, mu1, mu2, mu k. Okay? Then the samples obtained from each population with a sample size of n can be organized in the following table, like this. From population 1, from population 2, y samples y21, 22, 2n. First subscript is what? The number of population, y2, second population. This one, yk, they are sample, yk1, yk2, oops, it is error, yk2, and ykn, right? Subscript. Here, yij is a random variable, like this. We studied here population x, then we say sample x1, x2, xn, like this. So, but now we have two subscript, okay? Yij here is the jth sample from second subscript from i's population. You understand that? Double subscript. Okay, see chapter 3.1 that I explained this kind of a thing. Chapter 3.1. Then yij, okay, yij is sum of mu I and epsilon ij. Okay? Okay. And epsilon ij assumption follows normal distribution with mean 0 and variance sigma square. Then what is this? Yij has normal distribution with the mean mu I variance sigma square. Right? It is equal. And say Yij, yi1, yi2, yin is what? From population, i's population, yi samples. So iid, normal distribution with mean mu I variance sigma square. It's same body, same thing. This is the basic model for ANOVA. So you have to understand how this model comes from later on in this chapter. This is the explanation of model. So model is not that difficult thing. I hope you understand this basic model for this chapter. All right. Thank you so much today. That's it.